Hi everyone, welcome to the course on social network analysis, and this is chapter 2. This chapter is on network measures. So in the last chapter we have actually discussed why social network analysis is an important topic or a subject for an academic curriculum, and why people really care about understanding social networks, right? What are the potential applications? We have seen different types of networks, social networks. It can be social networks, it also can also be, say, biological networks, information networks, and how people essentially model, right, a complex system in terms of a network, right? We have also seen properties. We have briefly talked about different types of properties which we generally use to characterize a social network, right? So in this particular chapter, we will measure a network. Okay, now what do I mean by measuring a network? We will basically look at different components of a network or different entities, different parts of a network, right? If you remember correctly, in the last chapter, we have talked about 3 levels of analyzing a network: microscopic level, macroscopic level, and mesoscopic level. We will discuss different properties for every level of a network, right? And then we will try to characterize different components of a network. It can be an edge, a node, or a subgraph, and so on and so forth. Okay, so let's get started. So I will start this chapter by discussing these 2 interesting social media content, right? Both of these content went viral. I'm pretty sure you guys are aware of the virality of this content. The first one is Gangnam Style, right? And this went viral in 2012, and this is we all know that this is basically a South Korean pop song, and this went viral in 2012. And the second one is an Indian song, Kolavaridi, right? And this also went viral within a very small amount of time, right? Within a very small span of time. Okay, so I mean, of course, this is, I mean, what's interesting here? I mean, the rhythm was good, the music was catchy, the video may also be catchy, right? So what's new about these 2 songs, right? Why suddenly we need to discuss about these 2 songs in this particular chapter? Okay, so there are many papers. If you look at the papers, right, there are actually papers which studied why, say, songs like Gangnam Style went viral. Okay, so this is not only about the rhythm or the song's quality or the video, right? Of course, we all agree that these things were actually good in this particular song, but there might be some other factors which actually helped these 2 songs went viral. Okay, so let's talk about Gangnam Style, right? So Gangnam Style, if you remember the history, right? When this particular video was uploaded, right? Britney Spears, right? So she tweeted about this song, right? And that created a huge amount of tweets or retweets, right? According to the Wikipedia, after Britney Spears' tweet, there were around 1.3 million tweets containing the term Gangnam Style, right? And that too within a very few days. Okay, so here one factor could be the tweet by a very popular celebrity like Britney Spears, right? And if you look at songs like Kolavaridi, again according to Wikipedia, upon release of this particular song, the hashtag Kolavari, so that topped the that topped as a hashtag, as a trending hashtag on Twitter, right? Particularly in the Indian context. Again, this is, the time is around I think 2011 November, right? And immediately after that, we have seen cases where celebrities started, retweeting about it. It also, I think it was also played in US radio station, right? In November 2011, right? It had, I think, more than 10.5 million YouTube views, right? So, and the rest is history. So if you look at, social, I mean, if you look at standard, the sources, authenticated sources, you will see the, the studies on this, on these two songs separately. So one important lessons that one can learn is that, if you really want to make something viral, right, you convince some celebrities, right? Say you can convince, say, Shah Rukh Khan, for example, right? Or you can convince some political leaders, for example. You can convince some actors, some actresses who are celebrities, so-called celebrities on social media, right? You may also have heard about, something called viral marketing, right? Say for example, you have launched your own startup, right? And you do not have enough money to promote your startup, right? What you can do, you can hand over some of your products to some celebrities and let them try your products, right? And then if they are satisfied with your products, and then you request them to write about your products on say social media like Instagram and Twitter, right? That can be one way. And there are actually cases, I know plenty of such startups who actually adopted these particular techniques, right? They did not have enough money to promote their startups, and they basically gave these products to some celebrities, some well-known figures on social media, and those celebrities actually posted about their startups, and then automatically the startups got traction. Okay, so this is one of the strategies, right? But there is no free lunch, right? So meaning that when you convince somebody, right, either you give him or her money, right? But the amount of money that the celebrities will charge, that might be higher than the total budget of your startup, for example, right? So in some ways you have to convince popular users on social media to promote your product or to promote your brand, for example, right? So immediately the question is, how do we measure who is a popular user, right? Now, since that, say, people like Shah Rukh Khan or Sachin Tendulkar or Britney Spears, they are actually popular because of their work. But sometimes from a naive user's point of view, who, say, for example, who doesn't have much idea about the activities, right? So let's say you give that user a particular network, right? So by the network, what I mean to say is that you have set of nodes and set of edges. How do you measure, or how do you identify, or how does a naive user identify that these nodes are popular nodes, right? These users are popular users. So in this particular chapter, we are going to discuss about many such measures by which you can identify the popularity of a node, right? Or a popularity of an edge, for example. So I have given you one case study where popularity metric, right, is used, but you can also use it in many other cases. And remember, the notion of popularity is not sacrosanct, meaning that depending upon the applications, you can think of different types of popularities, right? We'll discuss about many such notions in the following slides. So what are some interesting questions that we are going to discuss in this chapter? The first question is, what is the dynamics when a post receives high visibility on online social media, right? Is this natural? For example, if I post something, right, versus a popular user or a celebrity posts something, right, the quality of the posting, right, the quality of the text, the content may be same or may be similar, right? But why my post, doesn't receive enough popularity, whereas the other post receives a lot of popularity. What's the dynamics behind it? So we'll discuss about it. How to, publicize a post on online social media, right? And this is related to the previous question that we have asked. The third one is how to find social media celebrities, the one that I was mentioning, right, in such a vast online world, right? If you say do not know, let's say you are analyzing the social network of say France, for example, right? And you do not have ideas about the kind of work that the celebrities do. For example, who is the celebrity in the space of movie, who is a celebrity in the space of sports, and so on and so forth, right? You are only given a network. Now, based on this, how do you measure the popularity? The fourth one is how to identify the prolific users in a specific domain in social media. So popularity is a very generic term, right? Now, if you focus on a particular domain, right, let's say sports, or let's say movie, right? Now, in this particular genre or a domain, how do you identify that, okay, this user is popular or this user is more popular than the other user, right? The fifth one is what are the role of prolific users when a post becomes viral in social network. Now remember, it is not the case that every time when a particular post becomes viral, there is a celebrity or a popular user behind it. It may not be the case. In fact, there are plenty of such cases, right, where we have seen that a normal, a simple tweet, for example, you may have seen songs which became very viral. For example, this Kacha Badam, right? Now, this song went so viral, but there is no, it is not the case that, it started from a post of a celebrity, right? So there might be other factors, and we'll try to dig deeper into understanding the other factors behind such virality. Now, in this particular chapter, we will briefly talk about some of the factors, but we have a separate chapter altogether where we will discuss, how a particular post becomes viral and what are the dynamics behind it. The next question is how to determine if two social media users are similar in terms of online activities. Let's say you have user X, user Y, right? Now, user X has its own network structure. User Y has its own network structure, meaning that the neighbors are different, for example, right? If the neighbors are same, then you can also say that, okay, they are same. But say let's say they are different, but structurally, all the neighbors are different, but structurally, how these neighbors are actually distributed, structurally, it's same. Okay, so let's say two nodes, are located at two different regions of a network. But if you look at the distribution of fast hop neighbors of both these nodes, you see that, they look like a star-like structure. So can we say that these two nodes are equivalent or same, right? Now, why this is important? This is important in cases like, say, you want to replace a node by another node. Say, you want to replace an actor by another actor, right? If you somehow characterize the users based on the neighbor distributions or based on other factors, you will say that, okay, these two users are equivalent. So in certain applications, in certain activities, you can use user X than user Y, or you can actually, you can actually use node X instead of node Y, right? Because so you also need to understand that nodes or users may not be available every time. So say, for example, if you want to, again, let's take the same example of virality, right? Viral marketing. Say you approach somebody, but that person says that, look, I'm not available for another 2 to 3 weeks. So you need to basically approach to another person. Okay. So the last one is how do we know if similar users are connected in a network? Okay. So as I mentioned earlier, that let's say two users are similar in terms of some activities, but they are far apart from each other. So how do you know that they are connected? Right? Again, there are different notions of connectedness. We will discuss these notions one by one. So primarily, we will basically try to answer this 7 questions, 6 to 7 questions in the remaining part of the chapter. Okay, so now let's look at the metrics that we are going to discuss. So we will basically categorize metrics into 3 buckets. We have microscopic level of within this microscopic level we have metrics like degree, clustering coefficient, and node centrality. We'll discuss each of them one by one. We have macroscopic level where we look at the entire network as a whole. Microscopic level we look at specific entities like nodes and edges, the fine-grained entities in a network. Macroscopic level we look at the entire network as a whole, and we will discuss degree distribution, path and diameter, edge density, global clustering coefficient, something called reciprocity and associativity. And the third category is mesoscopic level of analysis, where we look at, so you remember last class we discussed that mesoscopic level is in between microscopic and macroscopic. So at mesoscopic level we look at different substructures of a network. It can be a component, it can be a motif, right? It can be a group, it can be a community, and so on and so forth. So particularly here we will discuss about something called connected components, giant component, and if possible group centralities, right? This is the flow of this chapter. So let's start with degree. This is the very basic very basic quantity of a node, right? So what is degree? So many of you know that essentially degree is the number of edges, right, that are attached to a particular node. Now this is a node centric property. So for an undirected unweighted network, there is no direction associated with the edge, there is no weight associated with the edge. For an undirected unweighted network like G1, right, in this particular figure, right, the degree of a node V is defined by the number of nodes in the network to which there is an edge from V, right? For example, right, if you look at node 3, so node 3 there are 4 nodes, 1, 2, 4 and 5, and you see that there is an edge from 1 to 3, from 2 to 3, from 4 to 3, and then 5 to 3, right? So degree of node 3 is 4. Now this this is apparently very simple metric, right? But later we will see that even a simple degree metric, right, I mean the beauty of this metric is in a different aspects. We'll discuss about that later. So so this is undirected, right? And say I mean you can also of course interpret it in different ways. For example, you can also say that the degree of a node is the number of edges of the network that are incident, right, incident on V. Now this terminology is very important. Okay, so I'm going slow because these terminologies you need to remember throughout the course, right? Degree, incident to a particular node, and so on and so forth, right? So you can also say that the degree of a node is the number of neighbors of a particular of the node V, right? So for example, here as I already mentioned, node 3 has degree 4, node 1 has degree 2, node 4 has degree 2, node 5 has degree 3, and so on and so forth, right? Similarly for G2, both G1 and G2 are undirected and unweighted. Let's think of weighted network, right, where weights are associated with edges. Okay, so for an undirected weighted network, the degree of a node is sum of weights of all the edges associated with the particular node, right? Say for example, for node 3 you see that there are 4 edges, this one, actually 5 edges, this one. Remember there are 2 parallel edges, right? Between 2 and 3 you see there are 2 edges, so these are parallel edges. Okay, so the degree of node 3 would be 3 plus 1 plus 9 plus 7 plus 6. Okay, similarly for degree 5. Similarly for node 5 or node 1. Okay. So this is very simple, but remember one thing, if a node has self loop, for example, like this, okay. So if a node has self loop, that particular edge contributes to 2 in the degree calculation. Okay. For example, let's go back and let's look at node 5. Let's say there is a self loop like this. Okay. So what's the degree of node 5? Node 5, the degree of node 5 is 1, 2, 3, 4 and 5, right? So essentially we need to look at the edge, number of edges that are incident on a particular node. Okay. Now let's think of a directed graph. So far we have discussed about undirected graph, directed graph. Let's think of a directed graph where there's a direction associated with an edge, right? So automatically you can think of 2 different notions of a degree. One is called in degree and the other is called out degree. So what is in degree? In degree of a node is defined by, so as the name implies, in degree of a node is defined by the number of incoming edges to a particular node, right? Remember here when you talk about an edge, now this edge actually contributes in 2 ways. So if there's an edge from A to V, say A to B, right? Let's say there's an edge from A to B, it means that this edge indicates an outward link for node A and an inward link for node B. Okay. Okay. So in degree of a node is defined by the number of incoming edges to a particular node. Similarly, the out degree of a node is defined by the number of outgoing edges from a particular node. Okay. So now we can think of, so for every node you can think of the in degree and the out degree, right? So let's look at this example G4, graph G4. Let's look at node 3. So node 3 has 1, 2 and 3 inward edges. So the in degree is 3 and there is 1 outward edge, this one. So the out degree is 1. Okay. Similarly, node 1, the in degree is 2, these 2 edges, and the out degree is 1. Okay. So when you talk about degree in case of directed graph, we actually need to talk about both in degree and out degree. Right. Now there is a very interesting property. Now this property is very intuitive, but it turns out to be very, very important in later part of this course. We will see different theorems where this simple theory is used, right? So it is said that for an unweighted undirected graph, okay, I will use the term network and graph interchangeably, both are same. Okay, for an undirected unweighted graph, the sum of the degrees of the nodes in a graph is twice the number of edges in the network. What does it say? It is saying that let's first look at, now remember this is unweighted undirected, so there is no notion of in degree out degree, there's only a degree, right? Now you take all the nodes and their corresponding degrees, okay, you sum them up. When you sum them up, the sum is same as twice the number of edges present in the graph. Okay, so sum of degree, right, say, right, this is 2 into number of edges. So this is mod. Okay, I represent a graph G by V comma E, where V is the set of, this is set of nodes, right, and this is set of edges. When I write the number of nodes, I will use mod V. This is the cardinality of the set, right? So this is the number of nodes, and I will use mod E as the number of edges. Okay, remember these terminologies, okay, and the notations as well. So you see that sum of degrees of nodes is 2 into number of edges. So why is it so? Now it's very simple to understand. Now think of a network, or think of a graph like this. Okay, say A, B, C, D. Each edge, let's look at this edge B comma C. Okay, this edge contributes 2 times to the degree. One time to the calculation of degree of B, another time to the calculation of degree of C. Right? So every edge contributes 2 times to the degree of node. Right? So therefore, if you take the sum of degrees, right, each edge contributes 2 times. So it should be 2 into number of edges. Okay? Think about it. Go back, you draw a graph, right, and you think about it. It's a very simple, theorem that is often used in graph theory and social network as well. So I stop here. So in the next part of this chapter, we will discuss, quantities which actually use degree as a fundamental quantity. Okay, we will discuss about something called degree distribution, and we will see that this degree distribution can be useful to quantify networks in a different manner. Even if you know the degree distribution of a particular network, you will blindly say that, look, this network should look like this. Let's think of a huge network, right? And you are not able to analyze the network, by just looking at it manually, by manual inspection. What you do, you calculate degree. Degree calculation is very straightforward, and then you plot degree distribution, and then if it follows a particular pattern, we will say that, look, this network actually looks like this. Okay, so therefore I started out by saying that although the notion of degree is a very simple thing, but it has a lot of applications. Okay, so I stop here. Next part we will discuss about degree distribution. Thank you.